Hi there. So, many of us are familiar with the idea of traditional relational databases, where we store data in tables, records, and rows, and then we use primary keys and foreign keys to model the relationships between these mappings of real-world objects. Recently, a new way to model these same relationships has come forth in the form of graph databases. So today I would like to talk about this extension for PostgreSQL called Apache AGE, which is just something that sits on top of your traditional Apache, on top of your traditional Postgres database, and then it allows you to use graph database techniques on top of your traditional relational database. And I would like to give you an example of this, and I think it would help better explain what I'm trying to get at and how this can be such a useful thing. So the only requirements are for you to have installed PostgreSQL, and you can follow along the instructions from the official documentation. And then you need to have installed Apache AGE, and here's the link to the official documentation. It's pretty easy to follow along. I'll add both of these in the description. And now, assuming that both of these are installed, I am going to log into my Postgres interface. So we'll start right at the beginning. I'm going to keep this very, very simple because I just want to give you an intuitive idea about why graph databases can be so useful compared to traditional relational databases. So here I'm going to just log in to this database that I created called AGE demo. It's a completely uh, new database, doesn't really have anything in it. It's completely empty, no tables, nothing. So if you see, if I query for tables, no relations found. So since Apache AGE is an extension, after you've installed, uh, according to the documentation, we are going to activate this extension by using the create extension command. Then I'm going to say age, and then I'm going to, sorry, I forgot my semicolon. Right, now I'm going to load it. And by the way, all of these instructions can be found on the official documentation. There you go. And now I need to set my search path. This is also just something from the documentation, but if you must know, basically we're using this namespace, we're providing it over here in our search path so that whenever we use our Cypher queries, uh, the Postgres knows where to look for them. Right. So that was just a bit of the prerequisites needed. Right. Now, let's try and solve a particular problem. Right. So first thing I'm going to do is I'm going to create this table. So I've created this table over here called employees. It's a very simple table. We just have an employee ID. I've used a serial primary key. Serial basically is an auto incrementing integer. And then we have the name of the employee. Then we have the ID of the employee's manager, right? And then we have the title. So I'm going to add some values inside this table that I've already set up. So let's try and query this table. Let's try and see what the data is. Select. Um, right, so this is what our data currently looks like. So these are just a bunch of writers that I've read. And so we can see that Gabriel is the boss. He doesn't really have a manager because he's the CEO. Then we have Dostoevsky, and he's a director, and his manager is ID1, which happens to be Gabriel. Same with Victor, works under one. And similarly, you can see that we have all the different kinds of employees in this imaginary company listed down. Now, say that we have a particular problem, and what we want to do is look at Franz Kafka. He is an intern. He obviously works under four. Who's for Albert Camus. And Albert Camus works under someone else, and so on and so forth. And basically, what we want to do is start from Kafka, who's very at the bottom of the chain, then move all the way up to Gabriel Garcia Marquez and find this hierarchy of employees that are directly above the intern. Now, first let's try solving this problem using a standard SQL query. So the nature of this problem is such that it is best solved through a recursive query. Now, right now, it might be easy for us to follow along this little chain of looking up the manager and then finding the corresponding ID. But you could imagine if we had thousands or hundreds of rows, this could be quite a complicated problem. There could be that there are two people managing the same person as well. So this would require a recursive solution to go all the way back up or all the way back down. So let's start writing a recursive query. So I'm going to just, right, use this right over here. All right, so let's go through this query before I run it. So if you're not familiar with recursive queries in Postgres, what we're basically doing is creating a CTE, a common table expression, using this with clause over here. I'm going to go over this query. So basically, a recursive query is set up in two parts. So we have this first part over here, which is our base case, which starts off our recursive chain. What we're doing is we're using a table called, we're just making this table called hierarchy. And then from the employees table, we're selecting the ID column, name column, manager ID column, where the name is Kafka. So what we're basically doing is, like, this base case is going to select one query, which is basically going to be something like this, that, hey, Franz Kafka, uh, this is just going to be our initial starting row, and it's going to be stored right here in hierarchy. Now, after this base case has had some data in it, the output of this is going to be the input to this part after this union statement. And this second recursive part is going to keep on running until we have no other rows that we can select. So this sounds a little confusing. It's because it is. That's just how recursion works. So basically what's going to happen here is that since we have this hierarchy table, and after the base case we have Franz Kafka, that single row in it, what we're going to do is we're going to join it with the employees table using this alias EMP. And from this EMP table, we're going to select the ID, name, and manager ID, where the manager ID of the hierarchy table is equivalent to the employee ID in the employee table. So basically what we're trying to say is that, hey, Franz Kafka manager ID should be equal to, who is number 4, right? So it should be Albert Camus, right? His emp ID. So this is going, so in the first pass of this recursive chain, we're going to get this Albert Camus ID selected. So now our hierarchy table is going to have two rows. And then now with Albert Camus in the mix, the next time the query is run again, we're going to look up a Camus manager and another row is going to be selected. And similarly, we're going to keep on going until all the rows are selected. So let's try and run this. So remember that this is a CTE, a common table expression. So I actually have, this is just me defining it, which creates a set, a virtual set. If you're not familiar with the terminology, that's fine. I'm just trying to give you an intuitive idea. So let's try and select this hierarchy. So I'm going to say select star from hierarchy, right? And let me see if I spelled it right. There you go. So here you can see that we have it set up. So here's Kafka. Manager is 4, Camus, manager is 2, Dostoevsky, and then we have Gabriel Garcia Marquez. So the problem is that while this solution did work, we had to think pretty carefully about how we needed to set up our query. And on top of that, while the results are readable, they're not the most intuitive way to read the results, since it's still in a tabular format, and what we're thinking about is more like something that could be visualized better using a graph. So why don't we try using some graph databases instead of using traditional relational databases? So this is where our Apache AGE extension is going to prove very useful. So I'm going to be copying and pasting a few commands just in the interest of saving time, but I'll try and explain them as best as I can along we go. So the first command is to create a graph. I'm just going to create a graph called EMP graph using this function over here. And you can go over these functions in the official documentation. I just want to give a quick intuitive demo about why this can be so useful. There you go. So we've created this graph. And now what I'd like to do, so what is a graph? A graph is a collection of vertices or points or nodes, and these points or nodes have different edges between them, which model the relationship between two different data points. So let's try creating a few vertices first, right? So I'm going to paste one query over here. It's going to look something like this. What we're basically saying is, we're using select star to create it, um, but this is the actual function, right? So I'm just going to quickly gloss over the syntax. So we have the cipher function. Inside it, we want to create a new vertex in the EMP graph that we just made, and using the create function, we are creating a node called employee, and these are the different attributes that we're giving that node. The ID of one, name of Gabriel Garcia Marquez, and the title is boss. And basically, I'm trying to model the exact same relationship as in the other traditional database, right? So I press enter, and it's created. I'm quickly going to add all of the other employees that I already have here stored beforehand, and there you go. Now, let's try and view these vertices, right? So I enter this command, select star from cipher, pretty easy. Uh, we use the EMP graph. This is what we're going to look up. And we just say, hey, okay, match everything that's an employee, put it here in this little V, and then just return that V. And then we just display it. So these are the different vertices. Don't worry if it doesn't look too intuitive. We'll get to that. Now let's try and create some edges between these different data points. So this is the code to create an edge. So let me just go over one, and then the rest will be similar in nature. So here we go. In the EMP graph, what we want to do is we want to match two employees. We're going to call one A, the other is going to be B. And we're going to say, okay, so where A is Dostoevsky and B is Gabriel, create an edge. And if you pay close attention, you can see this looks pretty, looks like an arrow, right? So A, arrow, B, pretty intuitive. So where Dostoevsky, we're going to give it a label, an edge, E, and we're going to call that supervised by. So Dostoevsky supervised by Gabriel. Just going to return that. We're going to create this edge, right? There. So now I'm going to add all the other edges for all the other employees. And there you go. We've created all of our employees. Now let's try and view this inside the terminal. So this is the command that I'm going to use to view it. From Cypher, I'm going to say, hey, match every vertex v1 with every vertex v2, and just give me the whatever the edge between them says, right? And then we're just going to display it. So let's try and see what this results. Okay, so here we can see, well, Victor Hugo, supervised by Marquez, so is Dostoevsky, Virginia Woolf as well, Lucien by this, and Kafka by Camus, right? So this is still better. This is better than our traditional database, right? It's a little more intuitive to see what this relationship is like. But we could go a step further and make it look even better. And this is where the very useful Age Viewer tool comes in handy, which is just a nice little nice little supporting tool that can help us visualize the database that we created. And the best part is that any query that works in the terminal, like we just viewed, can be viewed in Apache AGE Viewer. It's very, very simple to install. Basically, what you have to do is clone this, or even just you could download the zip. Uh, the only dependencies you need really are Node.js. And here's what you do. So you've got it here. For example, this is the extracted file or the clone file. You go to terminal, you run a command, you say npm run setup, right? And then you run this, it'll set it up, and then you just type this command in, and then it'll start the server, and your browser is going to load up this over here, right? It's going to load up this nice little page that you can use to make queries and visualize your database. So right here, I'm just going to say localhost, which is my URL, because I'm running um, this Postgres instance on this localhost. The default port used by Postgres is 5432. What's the name of the database? Well, I did say it was AGE demo, and I made it under my own username. I'm just going to add the password. Let's connect to this. All right, it says database connected successfully. Now over here you can see this little box. We can write our queries over here. So what I'm going to do, I'm just going to add a little query here, right? It's very similar to the one I showed you before. EMP graph, give me all the vertices V1 that have another V2 and the edge, and I just want to visualize it, right? I'm just going to press this button over here. There you go. So what do I see over here? Well, let's see. Let's try and zoom in a bit. Uh, all right, come on. My mouse isn't really working with me here. But here you go. Here you can see. I'm sorry if this doesn't look too good. Let me zoom in. Right. What were we looking for? Hey, this suddenly looks a lot more intuitive, right? Here we can see, hey, Kafka is supervised by Albert Camus. He is supervised by Dostoevsky. Lucian is also under Dostoevsky. And then Dostoevsky is under Gabriel Garcia Marquez. So is Virginia Woolf, Victor Hugo, and Murakami under Victor Hugo. Isn't that a much cleaner, nicer way to solve the same problem? And instead of having to think through some recursive query, all we had to do was just create the database and then make this very simple query that would help us visualize. The best part is you can try and rearrange the graph if if that didn't make too much sense. And here you can see that a lot of the in degree of this node over here is the highest, like so kind of can tell that this guy is the most important over here in this hierarchy. Goes all the way back to the top. So yeah, this was one of the use cases, just a very simple intuitive use case that displays how graph databases are useful. Now over here I had to create a whole this exact same database uh, right back as an entirely separate graph, right? So we had our relational database, then I tried to recreate the same database in the graph. What the real power of AGE comes from is that you don't really have to go through that entire process like I did, remodeling it but all manually. So there's something called hybrid querying, where you can use Cypher inside of SQL or vice versa, and then you can create really you can create these queries a lot better. Like you can make them a lot more optimized. You can make sure that these queries, uh, like the migration of data from a relational format to a graph format can be a lot easier. And maybe I'll explore that more in the next video. But for now, this is just what I wanted to give you guys a demo of. And I encourage you to download it, play around with it for a bit. Check out the OpenCypher language. That's what it uses. To just how there's a SQL standard, there's a Cypher standard. Check it out, play around with it, and hopefully you'll find it fun and interesting.